Hi guys, welcome to this set of videos. And in these videos, they're going to follow along with the notes that come from your guys' book, which would be Chapter 6, Section 6. And really what we've been doing, kind of the main theme here in Chapter 6 has been all about radical expressions. So these are going to be expressions that have radicals in them, or nth degree radicals, something other than a square root, like a cubed root or a fourth root, something like that. And we've been looking at different ways of simplifying those radical expressions. We even looked a couple of sections ago at graphing radical expressions. And now what we're going to do here in this section, again, continue with that theme of simplifying radical expressions, but now we want to look at what happens when you have a rational exponent and how that connects to radical expressions. But before we get into that, let's get a couple of objectives or learning targets so we have something to sort of focus as we go through this set of videos on the things that you need to be able to do by the time we get through this note set and these videos. So the first thing you're going to want to be able to do by the time we finish up with this set of videos is you're going to want to be able to write expressions with rational exponents in radical form, or vice versa, write something that is in radical form with a rational exponent, right? So we'll show you how to go back and forth between the two, and it's actually very, very simple, and you would just be rewriting expressions. That's all we're doing. We're not solving, we're not even really simplifying, you're just going to be rewriting it. So taking what you're given and writing it a different way. And then the last thing we'll look at today is going to be simplifying, continuing with this theme of simplifying, but now simplifying expressions that have exponential and radical form, right? So again, we'll have rational exponents, and technically that means you have something that's got a radical in it, and we'll look at all of that. So anyway, those are the things you'll need to be able to do by the time we get to the end of this set of videos. So here we go, let's jump right into it. What is a rational exponent? Well, you know that rational numbers are numbers that can be written as a fraction. And so what we're simply talking about here are going to be expressions where you have an exponent, but the exponent is a rational number. It's going to be written as a fraction. I have a perfect example of one right here. We've got a formula that gives you the relative strength of a sphere of influence for a particular planet, and all we're talking about here is how strong, where the gravitational force of the planet is stronger than that of the sun. And so anyway, this formula kind of allows you to calculate some things when it comes to that, but really the only reason I gave you the formula is I just want you to see I have an exponent in this formula, and that exponent is a fraction. It is the rational number 2/5. So these are the kinds of expressions that we're going to be working with here in this section, in this set of videos. What do you do when that exponent is a rational number? What do you do when that exponent is a fraction? Well, first, let me show you that actually rational exponents, fractional exponents, are really just radicals in disguise. And I can show you that right here. I've got a real simple little example for you to work through. There's a couple of ways that you can do this. I'll show you both. I've got it written out for you here, and what I have is I have a b to the 1/2 power. So that is a b raised to a rational exponent, right? 1/2 is a rational number. It's a fraction. So a b raised to a fractional power. What we're going to do is we're going to square that b. All right, so I've got a b to the 1/2, and it is squared. Well, we know anytime you square something, that means that you have two of those things multiplied together. So I'm going to rewrite this b to the 1/2 power, which is squared, as a b to the 1/2 power times a b to the 1/2 power, right? Because that's what squared means. You have the exact same thing multiplied by itself. But we know something about exponents, and we'll assume for the moment, and assume accurately, that we can treat rational exponents the same way we would treat integer exponents. And we can. When the base is the same, we add exponents. Well, I'm going to do that here, right? I have multiplication. My base is b in both cases, and so my exponents, 1/2 and 1/2, will add them together, because that's what the properties of exponents allow us to do when you're multiplying exponential expressions and they're multiplied together with the same base. You add the exponents. So we're going to add the exponents, and of course, 1/2 plus 1/2 is simply 1. So I wind up with b to the first. Well, anything raised to the first power is itself, and here's what that tells us. What that tells us is this. this original expression, b to the 1/2 power squared, b to the 1/2 power, if I were to square that, it simplifies to just a b. Well, hang on a second. If b to the 1/2 power squared simplifies to just a b, what does that mean? Well, that means, I showed you the algebra here, putting it simply, the 1/2 power and the square cancel each other out so that I'm left with just the b. Well, hang on, we know of another operation that cancels with the square, right? You guys know that if I were to give you, hold up, sorry, that's my highlighter. If I were to give you the square root of b and have you square it, well, what happens to the square root and the square? Yeah, they cancel each other out and you're left with just a b. But what I just told you is that b to the 1/2 power squared also is equal to b. Essentially, here's what we're saying. What we're saying is that the square root of b and b to the 1/2 power are the exact same thing. That's what we're saying. And that's exactly what we're going to be looking at in this section. How rational exponents, a fractional exponent, b to the 1/2, is really just another way of writing a radical expression. It turns out the 1/2 power is a square root. It's just a different way of writing it. I can either write it as a radical or I can write it as a rational exponent. And what we're going to look at here on the next page when we do a couple of example problems is this. Whatever the denominator is in your rational exponent, whatever the denominator is, will be the index when you rewrite the expression as a radical. Since the denominator is a 2, I would have an index of 2, which of course we don't write, 2 is implied, and I just write the square root of b. Let me show you how this works in a couple more example problems just to make sure you get the hang of it. If I were to give you b to the 1/3 power, well, since my denominator is a 3, that means I would make that the index, and this is equal to the cubed root of b. Means the exact same thing, two different ways of writing the same thing. B to the 1/3 or cubed root of b, same thing, same thing. B to the 1/4 would be the 4th root of b. Since the denominator is a 4, that becomes the index of my radical. One more, I know you guys get this, I don't mean to beat a dead horse, but b to the 1/5 would be a 5th root of b. And again, the point is simply this. Rational exponents are just another way of writing a radical, right? So anytime you have a rational exponent, a fractional exponent, we can and we will rewrite those as radicals, and vice versa. Our first objective, being able to go from a radical to a rational exponent. So let's get some practice on the next page. I got a couple of problems for you here, and all I want you to do is, like the directions say, rewrite. So what we're going to do is we're going to rewrite the expressions below in either radical or exponential form based on which I gave you. So let's jump right into this. Here we go. I give you an x to the 1/6. This is an expression with a rational exponent, right? This is in exponential form, so you will write it in radical form. Well, we know whatever the denominator is, that denominator will become the index of the radical. So this would be the 6th root of x. That's it. All I asked you to do was rewrite, and you did. You rewrote this exponential expression as a radical. Let's keep going. The next one, I have a 4th root of z. Well, whatever the index is going to become the denominator in my exponential rational number. So that means that this guy is going to become z raised to the 1/4 power. I have taken the radical expression and rewritten it as an exponential expression, right? Go in the opposite direction. Keep going. We'll fly through the rest of these. I think you guys have got the hang of it. Just a couple more here. This is going to be the 5th root of a. The denominator is a 5. That becomes the index on my radical. The 8th root of c means that I would have c to the 1/8 power. Okay, now we come to another one. This is d to the 7/4. Well, we already talked about the fact that the denominator is going to become the index. So since I have a 4, that means this is going to be rewritten as a 4th root. Okay, because the denominator becomes the index. But what about the 7 in the top? Well, it doesn't change, right? This will now be underneath my radical expression a d to the 7th power. And let me show you why. Check this out. Erase this real quick. I will come back to it. It's not wrong. I just want to rewrite it a slightly different way to help you see this. Remember, properties of exponents, right? Tells me that I can rewrite this exponent as d to the 7th times 1/4, because this would be the exact same thing. If I were to multiply 7 by 1/4, I would get 7/4. So I haven't changed anything, I've just rewritten it. Well, hopefully now it's maybe a little bit easier to see. What I have is a d to the 7th power. I can't do anything with that. I just leave it as a d to the 7th. But the 1/4, well, I know what to do with that. Since the denominator is a 4, it's going to be a 4th root. And so what we get is the 4th root of d to the 7th. And again, the simple way to think about this is whatever the denominator is becomes the index of the radical. If you have a numerator, it'll just stay a power on whatever the variable is. Got another one for you here. Careful though, this one's a little tricky. Please notice that this is to the negative 5th power. Watch out for that. We're not allowed to have negative exponents. That's going to mean something for us here in just a second. My index is a 3, so that's going to go into the denominator. So let me first rewrite this as c. The negative 5, right, will become the numerator in my rational exponent, so minus 5 over. The index of 3 will become my denominator, but we're not allowed to have negative exponents, right? So we know a property of exponents that says if you have a negative exponent, you take the whole thing to the bottom and it'll change the sign of the exponent. So I'll do 1 over c to the 5/3. Since I've taken c to the negative 5/3 and moved it into the denominator, that changes the sign of the power, so it goes from being negative to positive, and now I have 1 over c to the 5/3 power. All right, guys, that's how we take care of that first objective, which is rewriting rational expressions as exponential expressions, or vice versa, exponential expressions as radical expressions. Whatever the denominator of the rational exponent, that will become the index of your radical expression. Head on over to the next page of the notes and we'll take a look at a few more problems. I'll meet you guys there.